What's up guys? This is Julio G from Geespecautomotive. Recently, I decided to add the RX7 FC idiot warning light cluster service to the website. This has always been a common issue amongst the FCs, especially now that they're only getting older. I've had to repair these on almost all my personal FCs, so I thought I would offer you guys the option of sending them in to get fixed. And for all of you do-it-yourselfers, well, I'll go ahead and make this video for anyone that might want to try and attempt to repair themselves. And if that doesn't go well, you can still send it in after. With that being said, let's go ahead and get into the video. First things first, S4 series versus S5. What are the differences and are they interchangeable? Well, as you can see here on the left, the faceplate on the S4 unit ramps up. Now on the right with the S5 unit, the faceplate ramps downwards. The icons for the warning lamps also differ, but the casings and the connectors that plug into both of them are the same. You would need to at least use the correct faceplate in order for it to match your warning cluster surround bezel, so you don't have to change any interior bits. For this demonstration, we'll be looking at an S5 unit. To start off, you're going to want to remove the flathead screw at the center of this knob, then remove the knob itself. Now, you'll have these 3 Phillips screws. This is what's holding the casings together. I do recommend you use some kind of tray or cup to hold all your hardware, so you're not having to look all over the floor later when it comes time to reassemble. Unless you're into that kind of thing, then have at it. I also enjoy a good game of I Spy every now and then. Now that these are out, you should be able to slip the front casing away from the rear. We also want to remove the rear casing from the board itself. There's only 1 Phillips screw holding it on mine, but normally this board is fastened with 2. I'm sure whoever took this apart before me lost their game of I Spy. Let's get a little closer to show you how to unhook the board from the casing. You're going to want to get yourself a small flathead so that you can pry these plastic teeth away while simultaneously lifting the board. You'll have one on each corner. Don't be afraid of touching the board with the flathead. There is no traces we can damage while we're prying. If for some reason it's not coming up, double check you have all the screws removed and try again. Once you have it unhooked, I find it easy to use your finger to push on the pin from the backside to help lift the board the rest of the way out. I figured I would go ahead and pause the video here to give a brief description of what we're looking at. These black cylinders with white bands are called diodes. You can think of these as one-way streets. It allows power to flow one way and not back. The lighter cylinders with colored bands are called resistors. You can think of these as traffic cones. Just how traffic cones can be used to regulate the flow of traffic, resistors are used to regulate the flow of electrical current. All of these are different types of capacitors. These are used to store electrical energy, basically functioning like a battery. Now let's continue. This is the common failure point on these units. What ends up happening is the strain from the connector over so many years will cause these solder joints to start breaking, and that's where the intermittent issues come from. This particular unit had already been reworked and doesn't have any broken solder joints, but we'll go ahead and redo it anyways. What I'm using here is a solder sucker, and it does just that, suck solder. There will be a link in the description in case anybody wants to buy one. You could just reheat the old solder, but I personally like to remove it. Sometimes the solders don't mix well, so I just find this easier. Now that we removed the old solder, we can go ahead and add some while heating the solder joint. Be careful here not to overfill it and cause continuity between 2 contacts. What you want is for the puddle to drop and sink into the board. Once all is said and done, you want to have something similar to this. Again, keep in mind the spacing between solder joints. If you feel like yours are too close, you can remove it with the solder sucker and try again. Before we start assembling this, we're going to be replacing these board bushings. The purpose of these are to keep the boards away from each other. A majority of these clusters I've repaired, these have been worn just like this or non-existent. I went ahead and made some 3D printed replacements for these. I will be including a set with every service. Now if you want to buy some to replace your own, I'll have them linked in the site in the description as well. These are a direct replacement. All you have to do is line up the holes to the squares on the side of the board. The single hole is on top towards the clock unit, and the double is towards the bottom, facing the connector. Once they're locked in, make sure you give them a good squeeze. Installed correctly, they will look something like this. Now, we're finally ready to reassemble. We will go ahead and start by slipping the board back into the rear casing. Press the bottom board down until you hear those plastic teeth lock. Double check all 4 corners. If that all checks out, we can start by putting the fastening screws back into the board. Remember, there is supposed to be 2. With those back in, you're going to need to hold the top board flat while you throw the front casing with faceplate back on. The casing should naturally find its position with a bit of downward pressure. Make sure nothing is caught within the seams. Again, you'll feel and hear it lock into place. Once you're confident nothing's obstructing, go ahead and reinstall the 3 Phillips screws that hold the casings together. Make sure you don't strip the threads on these as they are going straight into plastic. Once it touches down, just give it a slight turn. Now, reassembly is complete. Don't forget to put your knob back on along with the screw that holds it. The last thing we gotta do is test it. I've gone ahead and marked the pins we need to hit in order to bench test this. Black is ground, top red is battery hot, bottom red is switched hot. I made sure to add some sleeving over the exposed ground terminal since it sits between the 2 hots. Last thing we need to do is short something out. Now to get our power source. Here, I'll be using my workbench to feed it 12 volts. Now, make sure you don't get these 2 mixed. Maybe even use 2 different colored wires. If you're questioning yourself, always double check. Just like that, we have a working clock unit. And if you followed everything correctly, so should you.